you use transformations when loading data using the copy command? There are several ways to answer this question. My recommended way of answering this question is we generally don't use transformations when loading data to raw tables with the copy command. The reason for this is because this tends to slow down the load on large files. We prefer to bring the data into Snowflake and then do the necessary transformations in SQL. There is an exception to this rule. The exception case is that in some cases we might receive very large files with over 1,000 columns. Now this 1,000 number is arbitrary, it can be any large number. In this situation, we might choose to load only a subset of the fields into the target table. In this scenario, we might need to use the select in the copy command and apply the necessary transformations. With that, we conclude this question. If you have the time, please join me in the next question. What is needed to establish connectivity between Snowflake and cloud storage? The first question we need to ask ourselves is that why do we need connectivity to be established between Snowflake and cloud storage? The answer to this question is to be able to copy data from cloud storage into Snowflake. We need to create a storage integration to establish connectivity between Snowflake and cloud storage. Once storage integration is created and the roles needed are configured and set, we can use the integration object in the creation of stages from which data can be copied to Snowflake or the other way around. A follow-up question that can be asked is, can you explain the steps in creating an integration object? You can see the storage integration syntax on your screen. Type equal to external stage, which means that the integration is between an external cloud provider and Snowflake and not using Snowflake's internal stage. Storage provider equal to S3 means the cloud service provider is AWS. This could have been Azure or GCP. Enabled equal to true. If enabled is set to false, we will not be able to use the storage integration. Storage AWS role ARN. This is the role in AWS which needs to be provided here so that the integration object has the privileges needed to access the cloud bucket and do the necessary action. Storage allowed locations. These are locations from which Snowflake can read data using the storage integration. Storage block locations. These are folders from which data cannot be read by the integration object. When we describe the integration object, it will provide us with an external ID, and this external ID will need to be updated in the AWS role in order for us to be able to use the integration object. With that, we conclude this question. If you have the time, please join me in the next question. How can we ingest data without using snowpipe, the copy command, or ETL tools like dbt? We can ingest data into Snowflake by creating external tables. When we create an external table on a cloud storage bucket or folder, we are able to get select access to files in the folder. We can use the insert into target table select star from external table to get data into Snowflake. This method is very useful when you have files greater than 250 MB, which is not suitable for loading with snowpipe. We can load files up to 5 GB in size with this method. An alternate method to ingest data is to create streams on external tables, which will enable us to ingest data in near real time into Snowflake from files that are added to cloud storage. With that, we conclude this question. If you have the time, please join me in the next question. You received files from your new vendor. You are aware of the layout of the file as they shared the details in the past. A target table was created with the file structure. Before loading the file to the target table, how will you validate if the file provided will load without any issues to the target table? The way we can do this is to use validation mode equal to return all errors in the copy command to see if there are any errors the file might encounter when loaded into the target table. When the copy command is run in validation mode, data is not loaded into the target table. Once you run validation underscore mode equal to return all errors in the copy command and you don't see any errors, you can go ahead and run the copy command without validation mode to load it into the target table. If you do get one or more errors when you run validation mode equal to return all errors, in that event you need to fix the file or tell your vendor to fix the file and then rerun the validation mode return all errors to check if the problem is resolved. With that, we conclude this question. If you have the time, please join me in the next question. How will you set up a process of automated validation and quality control of all files received from your source system before loading them to Snowflake? When running a job on a regular basis, we can validate files by using Python to read the files from S3 and check that the important fields and values are populated, and to throw an error if the validation fails. This way, what we can do is that we can remove the file before it is loaded into the target table. An alternate option is to ingest the data to Snowflake raw tables where all the columns will be of string data type, and run SQL to validate if the file is good before loading them further. Finally, we can use the skip file option to not load files that have load errors in them. So by using the skip file, if Snowflake copy command encounters an error, it is basically going to reject the entire file and not load any rows into the target table. With that, we conclude this question. If you have the time, please join me in the next question. Once a file is loaded into a table with the copy command, can you reload the file again? The answer to this question is, if you try to reload the file, Snowflake will ignore the file. And the reason Snowflake ignores the file is because Snowflake stores file load metadata which is associated with the table and is aware that the file is already loaded and will stop reload to prevent duplicates. The prevent duplicates part is very important. Snowflake prioritizes prevention of duplicates over everything else, and that is the reason why this is in place. This metadata is reset when the table is truncated or dropped and recreated. So if you truncate the table or recreate the table, what is going to happen is that Snowflake is aware that the table has been emptied out and will allow you to reload that file again into that table. A follow-up question that can be asked is, how can you reload the file even if it is already loaded? And the answer to this question is to use the force option in the copy command to force the loading of the files. And the use case that we see the force being used is when you need a large volume of data for performance testing. With that, we conclude this question. If you have the time, please join me in the next question. What is the data loading strategy on your project? If you get asked in an interview what the data loading strategy is on your project, essentially what the interviewer is trying to ask is, how did you go about loading data into Snowflake in the various scenarios and use cases you encountered? So in this question, what we are going to do is that we are going to talk about some of the scenarios and what solution we can use to ingest data into Snowflake. So we can use tasks and stored procedures to ingest data when data needs to be loaded in batch mode. Merge statements are generally used inside the stored procedure, and these merge statements update the target table when the stored procedure runs. For tables that need to be updated near real time, we can use tasks and streams. As you must already be aware, streams are Snowflake's implementation of change data capture and provide change in near real time. The task detects data in the stream, and the SQL statement associated with the task will update the target table. Here again, the SQL is generally a merge statement which uses the stream as input to update the target table. We definitely need to talk about snowpipe. So snowpipe is a mechanism of automatic ingestion of data files, and the file sizes need to be less than 250 MB and greater than 10 MB. This is a recommendation. It is not a hard and fast rule. IoT data best ingested in this way. So if you have IoT data coming through, definitely use snowpipe. It can be used for several other use cases, including those where data is actually coming through your source system. You can use external tables to ingest files that are over 1 GB in size. We can select data from external tables. By using the insert into select star, we can insert data into the target Snowflake tables. There is no hard and fast rule that the external table needs to be 1 GB in size. It can be a smaller file also, but if it is a 1 GB in size and larger, then external tables work well because you cannot use snowpipe and it might take a very long time to load the files using the copy command. Finally, we need to talk about streams on external tables. We can create streams on external tables, and when we create streams streams on external tables, new files that are added to the cloud directory will start showing up inside these streams. And this data that is showing up inside the stream can be captured immediately with the select statement and inserted into Snowflake tables. This pretty much covers what a data loading strategy can be present in your project. With that, we conclude this question. If you have the time, please join me in the next question. When ingesting data from data lake, are most of your files Parquet format or CSV? What is the reason for that? Let us take a minute to better understand this question. There are several patterns of ingesting data into Snowflake. One of the most common patterns that I have encountered is where data is pulled from various source systems. They come into a data lake, and then from that data lake, the data is moved into Snowflake. Since data is being moved into data lake before it is moved into Snowflake, we need to talk briefly about the storage properties of the file inside of the data lake. Data in S3 or Azure Blob Storage, when it is stored in Parquet format, it is very efficient because it helps conserve space. And since Parquet stores data in columnar format, it is very efficient when we select a subset of columns from Athena or Azure Data Lake Analytics. So if the data that was there on the data lake was being consumed only inside the data lake, what would happen is that storing it in Parquet format would be very efficient. Most data lakes store data in Parquet format because of this efficiency that Parquet provides. However, when it comes to copying data into Snowflake, Snowflake provides better performance with CSV file as compared to Parquet. CSV file has a 3:1 performance as compared to Parquet file when copying into Snowflake. The performance of Parquet is not bad. It is just that CSV is better. If most of your data that is coming into the data lake is being stored in Parquet format, the question that arises is that does it make sense for you to convert these Parquet files into CSV files in order to simply load them into Snowflake? And the answer to this question for most projects is no. We don't want to create duplication of data, consume more storage space, and go through the effort of converting Parquet files into CSV files just to copy them into Snowflake. The best thing to do for us is to use the Parquet files and copy them into Snowflake. It will be a little slower, but the speed is not all that bad. Finally, the enterprise standard that organizations set for storing data in the data lake is Parquet, as Parquet data can be consumed very efficiently using Spark. Coming back to the interview question, when ingesting data from the data lake, what you should say is that most of the data that is being consumed by Snowflake from the data lake is in Parquet format, as this is the most efficient format for saving data on the data lake, and the Parquet's performance with the copy command is not all that bad, and hence we use Parquet primarily for the ingestion process. With that, we conclude this question. If you have the time, please join me in the next question. What is data unloading? As most of you would already be aware, data unloading is the process of moving data out of Snowflake to cloud storage. We unload data with the help of the copy command. This might come as a surprise to some, but the copy command can help us copy data into Snowflake, and also it can help us copy data out of Snowflake. We need to know why unloading of data is needed. One of the reasons why unloading of data is needed is because Snowflake might be the source of the data. Let us say that you have a web application and Snowflake is the database for that web application. So your Snowflake database is the place where data is getting created on a regular basis. Now there might be a need to move that data out of Snowflake to other applications, and for that reason you might need to unload data from there. The second reason why you might need to unload data is because you might bring in raw data inside of Snowflake, do processing of the data by running a bunch of stored procedures and complex calculations on it, and when you have the final answer or the final result of that computation, that computed result might be needed elsewhere, and for that reason you might have to unload that computed final result to make it available in a different place. Finally, a common use case that I encounter is that business users want data in XLS format. So there is a table, there is data in it, and they want to review the data, and when they want to review the data, they do not want to review the data inside of Snowflake. They prefer XLS format. So what we have to do is that we have to unload the data in CSV format, change it to XLS format, format and make it available to the business user. So this pretty much covers what data unloading is and why data unloading is needed. With that, we conclude this question. If you have the time, please join me in the next question. When unloading data into cloud storage, what best practice do you use? The best practice that we need to consider using when unloading data is the partition by column name. Now, what happens when we use the partition clause in the copy command is that we are able to use the parallelism feature of Snowflake. Now, the field market segment is a column inside the customer table that we are trying to unload. And what Snowflake does is that with the help of this copy command, it breaks up the file based on the market segment that is present inside the data. In addition to that, we can also provide the files that are generated a name. In this particular case, we have used the name cust to represent customer. If I don't use the word cust, the copy command will provide it a generic name like data underscore. So in this copy into command, what we have done is that we have used cust in order to give a meaningful name to the unloaded data, and we have used partition by in order to ensure that files are generated based on the data inside of market segment. Let us jump into a demo to see how partition by market segment works. I'm going to start off by using the Snowflake schema. I'm going to select data from customer so that we can see how the data looks inside of market segment. So there are a bunch of fields here and we are interested in market segment. Let's run a count to see how it looks. As you can see, these are the following values inside the field market segment. Because we used the partition by clause, we should expect to have 5 different files inside our unload folder. The next step is that we create a database called MyDB. We are going to create a schema called MyStages. Here we create a file format called CSV file format because we need the file format for our unload process. I'm also going to create a stage out here, and this stage basically contains the folder Sujit load data, and then it is followed by a folder called CSV in which I'm going to unload the data. Now before I unload the data, I'm going to show you the folder so that we can see that it is empty. Right now we are in the folder Sujit load data, and this is the CSV folder. As you can see, this folder is currently empty. Now that this folder is empty, we are going to go back into data unloading and run the unload command. So there were 2 things we did here. We partitioned by market segment, and the other thing we did is that we used a prefix called cust. Now let us go into the data and let us see whether we can see it. I'm going to refresh the tab, and as you can see, I can see a folder called cust which matches up with what we set here. I'm going to go inside it, and as you can see, it is further divided into folders depending on the market segment that was present. So as a best practice, what we should do is that we should partition by a field that makes sense to us. Now we could have partitioned this by any other field. If you have transaction data and you want to transaction by dates, then you could have done that by dates also. So depending upon your need, you can choose the partitioning field. So coming back to the question, when unloading data into cloud storage, the best practice that we need to follow is to partition by a field that is relevant to the data and to our consumption, and also give it a name so that it does not use generic names. With that, we conclude this question. If you have the time, please join me in the next question. Was there a scenario in your project where you had to unload the data to an internal stage? Now, there are 2 types of stages in Snowflake. There are internal stages and external stages. External stages are essentially cloud storage like your S3 with AWS or Azure Blob Storage with Azure. Now, there are some organizations that do not use cloud storage like S3 and Azure or AWS or Azure, and they rely on internal stages in order to run copy command to move data into Snowflake or to unload data from Snowflake. So with that perspective, this question talks about unloading data to an internal stage. The most common scenario that I have encountered when we have to unload data into an internal stage is when the business user asks for data that is present inside of Snowflake tables. If they want data inside of Snowflake tables, what we need to do is that we need to run the copy command and unload data out of Snowflake and bring it to the the internal stage, and after bringing to the internal stage, we can download it using the get command. Generally, what happens is that the copy command will produce multiple files when you run the copy command. In this particular scenario, because we want to provide the file to an end user, we need the entire data to be inside one single file, and for this reason we should use the parameter single equal to true to ensure that the unloaded files do not get split into multiple files. Let us jump into a demo to see how we can unload data into an internal stage. We'll start off by using Snowflake sample data database. We'll follow that by using the schema tpch sf1. We are going to select data from the customer table. This is our candidate for unloading data. Creating a database called my database. Now we are going to create a schema called my_stages. We are creating a file format called csv_file format. We need this file format during the creation of the stage. The next step for us is to create an internal stage. So we do create or replace stage name. The name of the stage is internal stage, and we have provided it a file format. Now the file format we provided here is the same file format that we created here. Now before I do anything, let me see if I have any files in my internal stage. There are no files. I just created the stage, and so obviously if I just create the stage, there are going to be no files. Now I'm going to unload data from the customer table into the stage my internal stage. The unload command worked. Now let me list to see if there is data. As you can see, I can see one data file listed there called data. Now, since this is one single file, what I can do is that I can download this using the get command and then change it to XLS and share it with the end customer. With that, we conclude this question. If you have the time, join me in the next question. Do you prefer unloading data into multiple files or a single file from Snowflake? The right answer to this question in most cases is multiple files. And the reason for that is because we are able to take advantage of parallelism provided by Snowflake. Also, if you generate one file instead of multiple files, the time that it takes to generate one file is much greater than if you generated multiple files. Now, the default behavior for Snowflake is to generate multiple files, and the max file size that it generally generates is 16 MB. However, you could go up to 5 GB if you wanted to, and at that point there is a limitation in terms of cloud storage support, and you cannot go beyond 5 GB. Now, from answering the question in an interview, the best way to tackle this question is to say that depending on the circumstances, in most cases, generating multiple files is better. Only in those scenarios where one file is required in order to share that file with a business user or with a business vendor or some other scenario similar to that, we would generate a single file by using the copy option single equal to true. With that, we conclude this question. If you have the time, join me in the next question. Can you unload data from multiple tables in a copy command? The answer to this question is yes. We can unload data from multiple tables in a copy command. Let me briefly talk about a scenario that I encountered when I was working for a healthcare insurance project. Now, we had to send out files every month of customers along with their claims to a vendor who basically ran analysis on the data. In order to send this file, we needed to join several tables. We needed to join the eligibility table, the claims table, and in addition to that, a bunch of other tables. We used the copy into command and we joined the tables that we needed in order to create one file from several tables. So being able to join tables in the copy into command to unload data is very, very useful. So coming back to the question, can you unload data from multiple tables in a copy command? The answer is yes. And Snowflake supports the entire syntax of Snowflake. You can use what is known as all the functions that Snowflake provides and everything else that Snowflake provides within the copy command in order to unload the data. Let us jump into a demo to see how we can join two tables in the copy command as we try to unload the data. I'm going to use the Snowflake sample data database. I'm going to select some data from the customer table. Here we can see all the fields that are there. Of particular interest to us is the nation key field because we are going to use this field to join it with the nation table. I'm also going to select some data from the nation table. As you can see, the nation table has the nation key and the name of the nation. So we know by looking at this that we can join the customer and the nation table on the nation key. In order to be able to unload the data, I'll start off by creating a database called mydb, and I'm going to create a schema called mystages, a CSV file format for use in the copy command. I also need to create a stage so that we can unload the data. I've used Sujit load data, and then there is a folder called CSV. Now what I'm going to do is that I'm going to go into this Sujit load data folder, and I'm going to see if there is any data present here. As you can see, there is no data in the CSV folder in S3. Coming back here, the next step for me is to run the copy into command, which is basically the unload. As you can see here, I have joined the customer and the nation table on the nation key column. Let me run this and see if this works. Hooray! I can see that I have successfully run the unload command. Now let me come here, refresh this and see if files are there. As you can see, 2 data files have been created. Because this copy command was not given a prefix, it came with the default name of data. With that, we conclude this question. If you have the time, please join me in the next question. How are Parquet files zipped when being unloaded? When unloading data from Snowflake, we have a couple of options when it comes to format of data that is being unloaded. For example, we can choose to unload the data in CSV format, a very popular format. We can choose to unload it in JSON, or we could even choose to unload it into Parquet. Now, what you would unload the data into depends upon the use case. If you had to send the data to a third party, in that event, you would typically do it in either CSV or JSON. However, if your goal of unloading the data was to save it inside the data lake or Azure storage so that it can be consumed by another application, then in that case, you would go with the Parquet format. Now, like all things data, compression saves storage and it saves us money. So what we want to do is that when we unload data, we want to make sure that the files that are unloaded into cloud storage are compressed. By default, Snowflake compresses files when it unloads the data. CSV and JSON files, their default compression is gzip, but we can choose to change the compression type to bzip or zstandard or something else. Now, when it comes to Parquet files, the default compression is snappy, and it is in fact the best compression available for Parquet. However, we also have LZO, and if we want to be different and we want to use that, we can choose the LZO format as a copy option when unloading data, and we can see the data inside the cloud storage in LZO compression format if we choose so. But there is no real advantage of going the LZO route over the snappy. Let us jump into a quick demo to see what happens when we unload data in Parquet format. We will try and determine if it compresses into snappy by default. I'll start by creating a database called mydb. I will follow that up by creating a stage called mystages. Since we are unloading in Parquet format, I'm going to create a file format called parquet_file format. I also need to create a stage, and in this stage I'm using the Parquet file format. Now that has been created successfully. I'm going to go into my Sujit load data folder and I'm going to refresh it. As of now, we see that there is no data here. It's now time to run the unload command. Let's go ahead and run it. The unload command was successful. Let's go into the cloud storage and refresh. As you can see, 3 files were generated. It is of type Parquet as shown here, and snappy represents the compression that was used. As you can see, the file format is Parquet and the compression type is snappy. Now we do have the option in the copy command to change the snappy to LZO if we wish to, if there is a particular need for it. However, snappy is the best compression for Parquet, and in the projects that I work, we use snappy with Parquet all the time. So coming back to the interview question, how are Parquet files zipped when being unloaded? We should say that the default compression format for Parquet is snappy, and if we wish, we can also use LZO for that. And in case the question talks about CSV and JSON format, you should say that gzip is the default compression type and the other supported compression types are bzip2, broadly, and zstandard. With that, we conclude this question. If you have the time, please join me in the next question. How do we modify column data types when unloading data? Before we discuss as to how we modify column data types, let us try and understand why we modify column data types. In Parquet file format, unlike the CSV and the JSON format, data types are maintained. That means when you define a Parquet column as string or integer or decimal, that data type is actually maintained inside the Parquet file format. So unlike a JSON or a CSV file format, data types matter in Parquet files. Having understood this, let us say that we had an application that was supposed to consume a Parquet file. If the data types inside this Parquet file was different from the data type that the application was expecting, then in that case, the application will error out, or in the best case scenario, will have to do implicit conversion when reading the data file. So when creating an output Parquet file, what we want to do is that we want to cast the existing data types in a manner that is consistent with what the consuming application will use. An example of consuming application could be Athena in AWS. We can create Athena tables in AWS and we can define Athena DDLs. And these DDLs that we define can have a particular data type. These DDLs can consume Parquet files, and when consuming Parquet files, the data type inside the Parquet file must be consistent with the DDL that we have defined in Athena. Instead of Athena, if you are in Azure, it could be Azure Data Lake Analytics, but the concept is exactly the same. If we had data types in Azure Data Lake Analytics or Athena, which is different from the Parquet file that it is consuming, we could have performance issues, or worst case scenario, there could be problems when reading the file and the output could be incorrect. Having understood as to why we need to modify column data types when unloading data, let us now come and discuss how to do it. We know that Snowflake in the unload command supports the entire gamut of SQL that Snowflake has. And so the only thing that we simply need to do is we need to use the cast function to cast a data type to whatever we want. In this particular case, as you can see on the screen, the cast key and the nation key are numeric values. I want to generate a Parquet file in which the cast key and the nation key are in string format. And for that reason, what I have done is that I have used the cast function to convert it. With that, we conclude this question. If you have the time, please join me in the next question. What problems have you encountered when unloading data? The reason the interviewer talks about problems you have encountered in an interview is because they are trying to understand the depth of your experience. So it is important for you to know a couple of scenarios in which you encountered problems. Now, when it comes to unloading data, the problem that I have encountered most frequently is existing files being already present in the directory, due to which the unload process fails. So essentially what we have to do is that we need to take steps to make sure that once files are unloaded into a given folder, they are then moved into a different folder. We move it to a folder called the archive folder so that the original folder is available to receive data again with the unload command. Now we can achieve that by using Lambda functions or Azure functions, or if the files that are unloaded are very, very large, like a 5 GB file, then in that case, we are going to have to write Python scripts which run on EC2 to move the data from the unload folder to an archive folder. One of the other problems that we can encounter when unloading data in CSV format or even JSON format, though I have not written it on this slide, is that data truncates to 15,9 in decimal columns. Now, you can overcome this problem by casting the data to string and unloading the data, because of which all the values that are there in the data are maintained. An alternative is to unload in Parquet format, in which case also the precision and scale is maintained. With that, we conclude this question. If you have the time, please join me in the next question. How can you limit the size of a file generated by unloading data from Snowflake? So the way we can limit the size of a file generated by unloading data from Snowflake is the max file size parameter. Now by default, the files generated are around 16 MB in size. You can use the max file size parameter to reduce it even further. Now, one question that might arise in our mind is that why have smaller files instead of having one large file? Instead of having 100 files of 16 MB, why not have one file of 1 terabyte or something of that kind? Now, the answer for that is faster processing. If you try to generate one file that is very large, the amount of time it will take to generate that file will increase substantially. Now, imagine that if you had to unload hundreds of files, if you keep adding this time, the total amount of time consumed will grow to a very large number. So, for that reason, you may want to have smaller files instead of one large file. The second reason for that is the ability to take advantage of parallel processing. Now, this in some ways is related to the first one, faster processing, but parallel processing is slightly different in the sense that if you had a multi cluster warehouse, it will be able to take advantage of that multi clustering and be able to generate files in a much faster fashion. Finally, the reason why you may want to have smaller files instead of one large file is that it is easier to consume by other applications. Now, let us say that you had an application that had a requirement that it can consume a file up to a maximum of 10 MB in size. In that case, what I would do is that I would provide this max file size equal to, 10 MB. This is in bytes, but it is about 9.5 to 10 MB. And then once that file is generated, we can make that file available to other applications to consume. Smaller files are easier to process too. So when you make these files available to other applications, they don't run into problems of having no compute or less compute. Another scenario that I have encountered in my project is that we unload data from Snowflake in order to FTP these files to end users or to FTP these files to our partners. And when we try to FTP very large files, we encounter a lot of challenges with them. So it is better to have several smaller files and FTP them over trying to FTP one large file. With that, we conclude this question. If you have the time, join me in the next question. What is a hybrid table? What are its main features? Hybrid table is a table type introduced by Snowflake that is designed for OLTP or transactional systems or workloads. Such systems, which is basically transactional or operational systems, need low latency and high throughput due to the number of transactions that are processed every minute. The number of transactions that are being processed is very high in transactional systems. Let's talk about hybrid table features and how they are different from regular tables. The number one is you can have primary key constraints, you can have unique key constraints, you can have referential integrity constraints, and all these constraints are enforced, which means you cannot put duplicates in the primary key or the unique key. And for referential integrity, the referential integrity must match between two different tables. And of course, you can create indexes which are used to improve select performance. So the question is, what is the use case for use of hybrid tables? As we just said, we discussed that operational or transactional workloads are the right reason why you would create hybrid tables. In addition to that, another reason is if you need high concurrency random point reads or writes, which basically means if you need to read or write one single record from millions of rows based on a where clause, in that event, we would use hybrid tables instead of regular Snowflake tables. With that, we conclude this question. If you have the time, please join me in the next question. Is Unistore, and what does hybrid tables have to do with Unistore? The word uni means one. When Snowflake says Unistore, what it means is that one store of data for all type of workloads. Now, what do I mean by all type of workloads? There are two type of workloads that generally exist for a database. They are the analytical workload, which is basically data warehousing, and transactional workloads, which is source systems like point of sale, which we can find at Walmart. With the analytical workloads, we can do data warehousing with facts and dimensions. And with transactional workloads, we have Walmart like systems, which is the sales system. Companies can use different databases for analytical workloads and different databases for transactional workloads. The reason that they use different databases is because different databases are designed differently, and some perform better for transactional workloads and some perform better for analytical workloads, and they generally do not perform well on both type of loads. Snowflake is designed for analytical workloads like data warehouse and not for transactional workloads. We all know that. However, with hybrid tables, Snowflake wants to change that and make Snowflake capable of handling transactional workloads too, in addition to analytical workloads. The term Snowflake uses is Unistore, which is a single store where both analytical and transactional workloads can run. We can create hybrid tables and regular Snowflake tables in the same database, and they can be joined together if there is a need to. Hybrid tables will run transactional workloads and analytical workloads will be run on the regular tables that Snowflake has. With that, we conclude this question. If you have the time, please join me in the next question. How are hybrid tables different from other table types like permanent tables? Hybrid tables have the following differences. The first thing you need to do is when you create a hybrid table, you need to use the hybrid keyword when you define the hybrid table with the create table statement. The second thing is that all hybrid tables need to have a primary key. It is mandatory and it is enforced. Without a primary key, you cannot create a hybrid table. The third thing is that you have the option to have unique constraints on a hybrid table. It is not mandatory, but you can choose to have that if your use case requires unique constraints. And also you can have indexes on hybrid tables if you want to improve the retrieval performance of your hybrid table. Along with these advantages or features of hybrid tables, there are definitely some limitations, and we need to look at those limitations. The limitations that hybrid tables have are as follows. You cannot have cloning with hybrid tables. You cannot have clustering keys with hybrid tables. Time travel, data retention, and undrop commands do not work with hybrid tables. You cannot create shares on hybrid tables. Dynamic tables cannot be built on hybrid tables. Just like time travel, fail-safe is not allowed. Materialized views are not allowed. Periodic rekeying, which is associated with encryption, is not allowed. Query acceleration service, which helps improve performance, is not allowed. Replication, which is used for disaster recovery, is not allowed. Search optimization service, which is used for query retrieval performance, is also not allowed on hybrid tables. Snowpipe and streams are not allowed on hybrid tables. Try-secret secure encryption and collation are also not allowed. So these are some of the limitations of hybrid tables. With time, some of these limitations might go away, but as of now, these limitations are there, and you need to be aware of these limitations as you decide to design hybrid tables and use them. With that, we conclude this question. If you have the time, please join me in the next question. Is Snowflake architecture different for hybrid tables? There is no change in the cloud services layer or the query processing layer architecture. They remain exactly the same. There is also no change in the way we access data from hybrid tables. We will continue to use SnowSite or SnowSQL. So what is different? If you look at the diagram carefully, which I have taken from the Snowflake documentation, hybrid tables have their own database storage area, which is different from the storage for other Snowflake tables. You might be wondering as to why this is the case. The reason is because unlike regular Snowflake tables, which are stored in columnar format, hybrid table rows are stored in row-oriented manner with secondary columnarization. Now you might think what secondary columnarization means. And what that means is that hybrid table rows that are row-oriented are also then stored in columnar format in order to enable quick read on analytical queries when there is a join between the hybrid table and regular Snowflake table. So from your interview perspective, the important thing you need to remember is that hybrid tables are separate storage which is basically maintained in row-oriented manner with secondary columnarization. With that, we conclude this question. If you have the time, please join me in the next question. Hello Snowflake engineers and welcome to the video. In this video, we will see the use of hybrid tables. What we will do is that we will create a hybrid table and we will check out all its features. Let's start off by checking the region. The reason that I am selecting the region is because hybrid tables today is not available in all regions. And since it is available in only a few regions, one being US West, you need to be aware of that. Also, hybrid tables are not available in trial Snowflake accounts. So if you want to practice hybrid tables, you will need to have a paid account, and you can convert a trial account into a paid account by adding a banking information or credit card. The next step I'm going to do is that I'm going to create a database called Unistore. Now I have chosen the word Unistore. This can be any word that you like or any database. It does not have to be Unistore. I'm going to create a schema called hybrid. It can be any schema name. It does not have to be hybrid. Just use whatever you want. The next step is for us to create a hybrid table. As you can see here, I'm using the keyword hybrid. Whenever you want to create a hybrid table, the keyword hybrid needs to be used so that Snowflake can understand that you are trying to create a hybrid table. Next, let us talk about the primary key. Hybrid tables must have a primary key. You cannot create a hybrid table without a primary key. So let me first try to get rid of this primary key here, and let me try and create this table and see what happens. As you can see, it gives me this error message which says a hybrid table must contain a primary key. So a primary key is a must in a hybrid table. Let me go ahead and run this. So the hybrid table has been successfully created, and this hybrid table also has a primary key. Next, we are going to insert a couple of rows into this hybrid table department. It has department ID 10, 20, 30, department name, leadership, tactical engineering, and of course the location name, which is bridge weapons and engineering section. Let me go ahead and insert the rows. Now that the rows have been inserted, I'm going to select data from the departments table. As expected, I have 3 rows which I just inserted. Next, I'm going to create an employees table. Now the employees table is a little more complicated. Apart from having a primary key out here, I also have a unique key. Now what a unique key is that it prevents duplicates from being inserted into the employee name. And I also have a foreign key references in which the department ID in employee references the department ID in departments. So any employee who is inserted into the employee table must have that department ID in the departments table. And finally, I have an index which I've created on the join date. And as you must be aware, indexes help in quick retrieval of data. Now let me go ahead and create the hybrid table. Hybrid table employees has been successfully created. It's time for us to insert a bunch of rows into the employee table. I'm going to insert employee ID 1, 2, and 3. James, Spock, and Scott with department ID 10, 20, and 30, which are departments that are already present in the departments table. The rows have been inserted. Let me select data to take a look at it. As expected, the rows we inserted is visible in the employees table. I'm going to go through a series of insert statements to see how the hybrid table will react when I try to insert it. I'm going to insert employee ID 1 again. Now, employee ID 1 already exists in the employees table, so let's see what happens. It gives me an error as expected. A primary key already exists. Now, the error message is not very descriptive. Ideally, it should have said a row already exists or a primary key row already exists, but we will have to make do with what we have. In the next one, I'm going to be inserting employee ID 4. Is employee ID 4 currently present in the employees table? No, it is not present. So do you think this insert statement will work? The answer is no. And the reason is because the department ID 40 that we have in this employees table insert statement does not exist in the departments table, and hence it violates this foreign key references, and hence the insert failed. Next, I'm going to try and insert employee ID 4 with second officer Scott in it. What do you think is going to happen here? Do you think I will be able to insert rows into the table? And the answer is no. Why? Because second officer Scott is already present in the employees table, and I have a unique constraint on the employee name. And since that constraint is getting violated, I cannot insert that row into the table. Let's come to the final insert statement. Do you think this insert statement will succeed? Yes, it did. And why did it succeed? Because the employee ID 4 did not exist in the employees table. Captain Christopher Pike was not present in the data already in the employees table, and department ID 30 already exists in the departments table, which I needed for the foreign key references constraint. So what we have seen in this lab exercise is that hybrid tables can be created and they require a primary key. They can be created with unique constraints. They can be created with foreign key constraints. And we can also create indexes on them to improve select performance. With that, we conclude this video. Thank you for watching.
Hi, Sujit. Good morning.
Hey, hi. Good morning to you. I'm doing great. How about you?
I'm doing good too. Thanks for asking. So, we are currently hiring for a Snowflake developer of 4 years experience, 3 to 4 years experience, and we have good opportunities based on the projects that we have. Right. So, can you tell me about what are all the Snowflake projects that you have worked on, and what are the Snowflake key functionalities that you have used?
Sure. So I'm currently working for Avis Budget Group as a Snowflake data engineer. And basically, I will start off by giving you an overview of the project. So the way the project is structured is that we have an AWS data lake, and we have what is known as Snowflake, and we have several source systems that are on-prem. And what we have been doing is that we have been trying to migrate out of what is known as an Oracle-based data warehouse and move into Snowflake. The way this migration is being done is not like a lift and shift, but it is a complete refactoring of the entire data warehouse, starting with data modeling. So essentially, what is happening is that we are extracting data from the source system in the form of files, and this data is basically running through a Python script extraction, which is happening on-prem, and then we are using a file gateway, SMB share, to bring the data into S3. And once it comes into S3, we have what is known as Python scripts that move the data along the various S3 layers. And once they are integrated into the data lake, they are subsequently ingested into Snowflake with the help of copy commands that are written inside of stored procedures. And we also use external tables. We also use snowpipe for what is known as IoT data. Since we are a rental car company, we get IoT data with location information of all our vehicles, and this information is pushed from by a vendor through a bucket-to-bucket copy into a folder from where we use snowpipe. These files are about 20 MB in size, and they are a good fit for snowpipe. So we use snowpipe for that purpose, and we ingest data using snowpipe too. So at a very high level, that is what it is. Yeah, for the data that is being ingested from the source systems, what we do is that we put the data into staging tables. And once data has landed into staging tables, we basically have stored procedures that read the data and write out to the target Snowflake tables, thus creating our data warehouse. Yeah, sorry, a lot of words. Yeah.
And this is good. So now I can understand that we have used Snowflake copy commands and also snowpipes and also external tables. Sorry. When you talk about migration from Oracle to Snowflake,
Mm-hmm.
how do you do that? As in, um, what's the primary difference that you feel between an Oracle system and a Snowflake system, and why do you need to migrate from Oracle to Snowflake?
Yeah, I think the primary reason why we are looking for migration from Oracle to Snowflake is data capacity and compute capacity. Oracle's licensing model is very, very difficult to deal with, and compute and storage are very, very closely related. Storage in Snowflake costs about $23 per terabyte or $40 per terabyte, depending upon the plan you take. And you can extensively add data without having to get into a licensing model where you need to pay excessively for compute. So this decoupling between storage and compute enables us to store enormous amount of data which we cannot store inside of Oracle, and at the same time we are able to achieve data lake integration, which enables us to improve our analytics considerably by storing a lot of data in the data lake and then bringing in relevant data into Snowflake. The ability to accelerate compute to a very high level gives us flexibility in the month end and the year end and quarter end jobs, where we can scale up compute substantially and what is known as end complete jobs rapidly. The highest cost for in most projects, especially in North America, is labor. And by increasing compute substantially, we are able to save developer time. And that is why, all these activities in the long run is going to help us. The other thing that we are doing is that we have enabled common code in the ingestion of data from what is known as the data lake into Snowflake. With Oracle, with the use of Informatica, we had to write specific code for every table that we used to ingest. Within Snowflake, we are using common code, common Python code to land data into the various buckets into S3. And we are also using what is known as dynamic SQL inside of Snowflake, along with stored procedures to populate Snowflake target tables.
We have started talking about architecture in Snowflake. Right? Can you tell about the different layers of Snowflake architecture and how they
Sure.
work?
Sure. Snowflake's architecture is unique in several ways because it is cloud first. It's a cloud first database, unlike the others. Even something like Redshift, which is a cloud database, is actually PostgreSQL that has been stripped out of a lot of things and converted into a cloud database. But Snowflake is cloud first. So they are basically Snowflake architecture is split into three parts: cloud services, query processing, and database storage. The cloud services, as we call, is the brain of the Snowflake system, where it has authentication and access control, where your roles and all that is taken care. And then, of course, then you have the metadata manager, and security is managed there. Then subsequently, you have the query processing, where you have a virtual warehouse where all the compute happens. And finally, you have database storage, which is essentially data that is stored on S3 partition. Now, since the most critical thing, when it comes to query performance vis-a-vis select queries, is the micro partition architecture that Snowflake offers. Data is split into micro partitions, which are basically about 550 to 500 MB in size, and these micro partitions basically have metadata in them, which basically store metadata information like the minimum and the maximum values, the ranges, the distinct values. And because we have these micro partitions out here, what happens is that when the query processing happens, Snowflake is able to do query pruning. So the micro partition architecture vis-a-vis storage of data is something that Snowflake excels in. And so that is something that I wanted to point out in terms of architecture. Coming to query processing, what we have is basically virtual warehouses. Virtual warehouses you have from extra small all the way to very very large like 6XL. Primarily, we can scale up or scale out. With scaling out means using multi-clustering, and scaling up means increasing the cluster size of the warehouse. And essentially, if you have a situation where you have a contention because of multiple queries, you would scale out. If you need increased compute, you would scale up. So that is where query processing comes into play. And the cloud services, as I said, takes care of security, role management. It also has a cache which stores information of previous queries, and helps optimize query and avoid consuming credits for repeatedly runs same queries. Yeah. At a very high level, that is what I would say. Yeah.
Yes, that is great. That is great. So when we are talking about Snowflake architecture, right? We are having multiple editions in Snowflake. That is,
Right.
what are those, and what's the primary difference between the services offered in those four?
Yeah, I'm currently working in Snowflake Enterprise Edition, and what I do know is that Enterprise Edition provides access to row level security with the data masking, and it provides 90 days of time travel that the standard edition does not provide. So these are the two major features that the Enterprise Edition offers that the standard edition does not offer. I do know that the business critical edition offers better protection on PHI data, but I have not worked in that, so I'm not exactly very sure what is happening there.
Sure, that is fine, Sajid. So we are having multiple types of objects in Snowflake, right? That is tables, different types of tables, views, procedures, etc. And some specific to Snowflake also, like stages, file formats. So what are all the different objects in Snowflake that you have used and that you are planning to use?
Yeah, so I have extensively used tasks in Snowflake. I have used stages because we need to create stages in order to what is known as ingest data. So we would create an integration object, connect the Snowflake to AWS, and then essentially create a stage such that it is pointing to that location. Then definitely we need to create file formats, and these file formats, you would create different file formats for CSV data, or if it is JSON data, you would create JSON data. We ingest a lot of data for using Parquet because our data lake format is Parquet. And the reason we use Parquet inside the data lake is because it is Spark optimized, and it is also got columnar compression. So we use tasks, we use stages. We also use streams in certain situations, especially on external tables, in order to ingest certain data rapidly into Snowflake. So apart from that, let me think what other objects are there. We do use secure views for data sharing. Most of our sharing happens between accounts within our own organization rather than sharing externally, because the data in within our organization, there is cross account demand. So we use data shares and we use secure views for that. So that is what I can think of at this point.
Sure, Sujit. Now let's talk about the different types of tables that are present in Snowflake, right?
Sure. Sure.
Yes.
Yeah. So the way Snowflake provides continuous data protection is by using time travel and fail safe. And basically, what we have is that we have three types of tables. We have permanent tables, we have transient tables, and we have temporary tables. Now, each one of these tables are designed for a specific need. So I'll start with transient tables. So if let us say that we worked in a typical data warehouse architecture in which what we did was that we loaded data and then we truncated a table, loaded data, and then moved that data into a target table, then in that event, that table that is holding the data does not need that data for more than what is known as 1 day, because that data is going into Snowflake permanent table schema. So in that event, transient table is a good choice. So what is a transient table is actually what I need to answer. So a transient table is a table in which the time travel is limited to 1 day and there is no fail-safe period. Now, fail-safe data is charged to the customer for 7 days, and if you were loading several gigabytes or almost one terabytes of data into a staging, you really don't want to have a lot of time travel and fail-safe data. So this can actually save you a lot of costs in terms of what is known as storage costs. So that is one thing. Now, temporary tables have a life only within its own session. Though it has what is known as a time travel of up to 1 day, for the most part, it is not very useful because the table will disappear as soon as the session ends. And these tables are optimum when within a stored procedure, and we have used this in our project, we temporarily need to ingest data and store it for calculations, intermediate calculations that are used by the procedure, but that data is not of any relevance after the procedure is done and the final calculation is done. So for that reason, global temporary tables can be used. They have no fail safe storage, and ideally you should just leave the time travel to 0. And then finally, you have permanent tables. Permanent tables are the tables which you can have up to 90 days of time travel. They are designed for storing data that you want to permanently store for a long time. Because you have 90 days of time travel, I don't recommend using 90 days of time travel. And the primary reason is because it costs storage for that. And especially if you have a lot of churn and updates, the amount of time travel data that will be present and fail-safe data that will be present will increase dramatically. So staying consistent with the organization's data retention policy, around 14 days is generally what I have seen in the organizations I've worked. Yeah, and you also have permanent schemas and permanent databases. So you could create those too. Yeah, and yeah.
Yes, we have both time travel and fail safe, right? So what's the key difference between the two? That was my question.
Right. Fail-safe is something that is outside of the control of developers and architects. Fail-safe is, if you want to access fail-safe data, you have to reach out to what is known as Snowflake support, and they may be, as per them, they may be able to get the data. Fail-safe is a backup of last resort. We should not plan to use fail-safe as a mechanism to what is known as capture data. We have to rely primarily on time travel. Whatever is the time travel period, we can go back to that ourselves by using before query or at timestamp, and or offset, as the case may be, and get the data ourselves without having to reach out to anybody.
Sure. So now let's talk about zero copy cloning. So why
Sure.
is it called zero copy cloning, and how do we use it in conjunction with time travel?
Right. So the reason why it is called zero copy cloning is because in zero copy cloning, no actual data is copied. So essentially, what happens when we do a cloning operation is that a new table is created, let us say, and it is basically a pointer to the same set of data that already exists on the micropartition S3 layer. So what is happening here right now is that no new data has been created, no new credit consumption has taken place. And essentially, since no data has been copied and no credit consumption was happened in order to copy over the data, we call this zero copy cloning. As the tables start getting updated, either one of the two new micropartitions will start getting created for the table that is getting updated, and then the data will start changing. So it is called zero copy cloning because at the time the data is the cloning happens, there is no actual data getting copied. It's only a metadata operation.
Now let's talk about stored procedures, right?
Sure,
So
sure.
what are all the languages that you have used for stored procedures in
So
Snowflake?
yeah, so in our organization, because we are a primarily data engineering team steeped in SQL, we primarily use only SQL inside our stored procedures. Though I know that there is JavaScript support, and that was the original language that Snowflake supported. So we use stored procedures with SQL because our team is mostly comfortable with that, and the folks that we hire are also primarily SQL based people with limited knowledge of, though we have the option of Python, we only use it as a mechanism of last resort if we are not able to code it inside of SQL.
Yes. Okay, that is good. That is good. Now, what is the difference between a user-defined function and a stored procedure?
Right. Functions and procedures. Yeah. So functions in general return a value, and a function cannot have what is known as a DML or a DDL inside of it. A UDF is basically called from generally from a select statement. So if let us say that I was, for the sake of simplicity, trying to calculate profitability based on order amount, and I was applying what is known as, I was passing the order ID into it, and it would basically calculate profitability of that order. So I could use a user defined function inside an SQL statement. Stored procedures are not designed to be used inside of SQL statements, and they can conduct activities like truncation of tables, insert, updates, deletes. So the essential difference is that user defined functions will be called from select statements, and stored procedures are run standalone or can be called from tasks or airflow, and essentially they can do a lot more in terms of truncation, deletion, updation. So if let us say that I wanted to run a merge command, and that merge command I had put it inside a stored procedure, so I could basically not put that merge command inside a function, but I could put it inside a stored procedure and have that stored procedure be get called from a task and run at whatever schedule I wanted to run.
So when we talk about scheduling and tasks, right? So how do you create tasks and how do you create dependent tasks and further set the schedule for a day or a week or a month?
Right. So basically, we create a tree of tasks with a root task, and subsequently, we create tasks by writing the after keyword, and thus we create a hierarchy of tasks. We schedule the root tasks, and the child tasks will automatically run, based on the as soon as the primary task is complete. So it would just flow through and go through the entire what is known as execution process. So we only schedule the root task.
Let's say we have a parent task that starts at 9 a.m. and the child task is starting by 9:03 or 9:04 a.m. and it is going until 9:07. Okay,
That is
but
right.
the main task is scheduled for every 5 minutes.
Right.
So does it restart by the 9:05 mark or does it wait for the child task to complete and so it can start by 9:10?
The default behavior is for it to wait till the child task is complete, because that is the default behavior. However, we can override that behavior if we want.
Now let's talk about loading data to Snowflake using the copy command, file formats, stages, and all.
Sure.
So in copy command, we have multiple options, right? Validation
Right.
mode and what is it? Similarly, we have many of the keywords, copy options that are available.
Skip file, abort transaction. Yeah.
Can you describe those?
Right. Yeah. So basically, there is an on error option, and on error option we can use things like skip file, abort transaction, or we can do percentage of errors on which we want to skip the file, either in terms of count or in terms of what is known as the number of records. Then in the case of snowpipe, skip file is what happens by default. And apart from that, let me just try and recall what other options are there. Yeah, we also spoke about validation mode. Validation mode, what we can do is that we can check to see before we load the file if there is a what is known as if there is what is known as any errors in the file. And if there are any errors in the file, we can actually it's basically kind of doing what is known as a pre-check before the actual loads happen. So those are some of the things that we can do. We can use force equal to true if we want to reload data. Again, that is one option that I can think of. And yeah, let me just try and recall. In the file formats, we can use null if to replace nulls. And the other thing that we can do is we can use optionally enclosed by quotes, which actually helps us to what is known as deal with those files which what is known as those files which have commas and then enclosed in double quotes. So these are the some of the ones that I can think of now. Yeah.
Okay, that is great. Now, I have a key question. Okay.
Sure.
So we have stages, or we also have file formats, and we also have the copy command. So
Right.
in the stage, we can mention what is the file format that is present, and we
Right.
can also mention that in the file format. Right.
Right.
And we also can mention that in the copy command, which
Right.
takes precedence.
Which takes precedence. So the one inside the copy command takes precedence, followed by the stage. So that is the order. So the copy command takes precedence, followed by the file format, and then the stage.
Okay, that is perfect. So now when we were talking about different types of files that are getting loaded, and you were saying CSV, Parquet, JSON, etc., right?
Yeah.
So how does that unstructured data get ingested to Snowflake?
Right. So what? Yeah. So the semi-structured data. So we are basically going to create a file format, and we are going to create a stage. So let's take for the example, we are using JSON. So we will create a stage and we will say type equal to JSON. And now that the type is equal to JSON, what we can do is that we can copy JSON data from wherever we want to, which in most cases is the cloud storage or internal stage, and then basically bring it to the table that we want to. Now, because you have declared a JSON stage, you need to make sure that the file is also of JSON type. And basically, it would go into a target table with one column, which will be of the type variant, so that it can be loaded in there, which subsequently we can parse out and load into tables in relational format.
That is great. Now, when we talk about this variant column, right?
Mm-hmm.
So how do we traverse? What command that we use to traverse through these subcolumns? Instead of a better word, how do we go to a subcolumn and see whether data is present for that variant subcolumn or not?
Right. So there are actually two ways of doing it. So we have arrays, we have objects, and then we have variant. And basically, a combination of array and object basically creates a JSON. So typically, what we do in our projects is that we use the lateral flatten to flatten out the array or the object or the JSON. Right. There is definitely the option of using the double colon and accessing the first level and then the colon and accessing the subsequent level, but we generally don't use it because we don't know how long or big the array is.
That is so. When we talk about arrays, right? How do we create arrays inside a variant column in Snowflake? If at all we want to create array of multiple JSON objects, what is the keyword that we use to create even a JSON object, a variant column?
Yeah,
And
so I
also,
think there are two functions that support creation. One is parse JSON and two variant. I think we can use either one of these. I have generally used parse JSON to create what is known as like if I'm inserting, I will use parse JSON, put the JSON in, and then if I'm doing it from my Snow site, that is how I would do it in order to insert it into the target. Yeah.
awesome. That is also the keywords that I was looking for was object construct and array construct, using which we will be able to create arrays itself, JSON arrays
Okay.
itself. Yeah. So
Okay.
I have
Let me
used
now,
that
now that you say that, let me just think about it. Object construct is used to convert relational table into JSON. So basically, what you are asking is that how to convert relational data into JSON data. Okay, yeah, we would have to use object construct. Okay, yeah. If I was doing it from Snow site, I would use parse JSON. Otherwise, I would use object construct. Yeah, I completely agree.
So, okay, next is SnowSQL. Okay, now we can install SnowSQL in our command prompt, right? And then use it to upload and download data to and from internal stage. Okay, before this, let's talk about different types of stages that is
Right.
available in Snowflake.
Right. So at a very high level, we have internal stages and external stages. External stages are basically cloud-based storages like S3 and Azure Cloud Storage or Google Storage. And internal stages are the three types: the user stage, the table stage, and the named internal stage that we create. So in our projects, I primarily use what is known as named internal stages and external stages. We generally don't use user stages, which is automatically created when a user is created, and table stages, which is automatically created when a table is created. We can use the copy command with either of these three internal stages, user, table, or internal, in order to copy the data over to a target table here. Yeah. And the external stage, of course, we need to create a storage integration so that there is connectivity established between the stage, like which, yeah, in order for them to be able to communicate. Yeah.
That's all. Now we can talk about SnowSQL. So how does SnowSQL authenticate, and how do we upload a local file to internal stage and also download files from internal stage to local?
Yeah, so there is two options basically for internal stage. One is that we can use the Snow site UI, click the table, and then there is an option to upload. There is a limitation of what is known as 50 MB on that kind of an upload, where you can actually go ahead and upload it into internal stage or the table stage or the user stage. And if you don't want to do that, you can always log into SnowSQL, assign the warehouse, and then use the put command to put the file into the what is known as into the internal stage, and then basically use the copy command from that point to copy it to the target table. So I wanted to briefly talk about the internal stage. We extensively use internal stages when we want to unload data out of Snowflake. When the business user wants data from a specific table, so we extensively use internal stages to unload data by using the copy command, and then download the data using the get command, and then make it available. And we use single equal to true so that we just get one file instead of multiple files. Yeah.
Yes. What are the different types of authentication that is allowed in NoSQL, like username, password, external browser, and what else?
Yeah, there is key pair authentication that is allowed, which is there in addition to username, password, or using MFA and all that. So the reason I bring about key pair authentication is because, let us say that like there was a scenario in one of the projects that I worked where basically we had files getting generated on an on-prem server, and these files had to be what is known as uploaded into an internal stage. And the reason that this organization was using an internal stage was because they did not have cloud storage. So they were heavily reliant on internal stages because they were using Snowflake just like how you would use Oracle without the use of cloud. So you can use key pair authentication, and using that you can basically use a script and the put command to what is known as push the files into Snowflake, and thus you don't need someone to come in and put the username password manually and move data to the target stage. Yeah.
Okay. So when we talk about single file or multiple files, right?
Right.
So when multiple files are getting created using in the internal stage, what is the file limit of a single file? Or for a single file,
Yeah. So on the
what could be the
external
maximum?
stages, in AWS, I think it is 5 GB. On the internal stage, I don't exactly remember what it is, but by default, 16 MB is the file size that is always generated. Generally, the copy command does not create files greater than 16 MB unless you force it to.
So, do you have any questions for me? This has been a very informative and interesting session.
Right. Can you briefly tell me about the project that that you are recruiting for, so that I can get a better handle of what is happening?
Yes. So in our project, right, what we do is we have multiple CSV files and parquet files which we ingest, and post that we create dimensions and facts based on that data, like a traditional data warehouse. But the key difference here is we use the time travel extensively every day to check the SCD type 2 transformations that we need to do. That's why we have started using Snowflake primarily. In addition to that, we use the performance tuning methodologies for clustering. We use query profile to optimize all our queries. And we primarily use Azure external stage for ingesting the files. So, this is the project, general profile of our project. And
fantastic.
we use row access policy and dynamic data masking also, because all our stakeholders don't need to view all the data that is present. So these are all the key points of our project.
Okay, really nice. I am definitely interested. If you think I am a good candidate, I would definitely be interested in working on the project, and and looking forward for feedback from you soon. Yeah.
Sure, Sumit.
Okay, thank you very much. Yeah, you too. Thank you. Yeah, bye.
We had a very good session. Thank you very much. Bye.
Bye.